One, two, three.
Assalamualaikum warahmatullahi wabarakatuh. I'm Ludfira Ekaputri, and today we will talk about Brinicle. What is Brinicle? Are Brinicles dangerous, and how Brinicle form? And enjoy the video. The salty water of the ocean has a lower freezing point than fresh water. While fresh water freezes at 0 degrees Celsius, while seawater in the Arctic and Antarctic region has been recorded at -1.9 degrees and colder. When the frigid air temperature is enough to freeze, the crystallization that takes place also differs from that of fresh water. Instead of a solid mass of ice, seawater often forms a spongy crystalline structure with channels of concentrated brine or salt water within it. Since this brine is denser and heavier than the surrounding seawater, it pulls and migrates through cracks in the floating sea ice. When it reaches the less concentrated water below, it begins to sink. As the brine is also colder than the water through which it is passing, the seawater freezes on contact and crystals of ice form around it. When these ice crystals form a tube around a descending column of brine, a brinicle is formed. The word brinicle is a contraction of brine icicle. They are also called sea stalactites due to their resemblance to this common cave structure. Brinicles, however, are not hard like rock. The crystals are delicate and can be broken by the slightest touch. When the brinicle reaches the seafloor, the cold brine expands outward across the seabed. A web of ice crystals may form along this progression, resembling a river of ice. The entire process generally takes between 4 and 12 hours. Brinicles are not dangerous to humans, as man seldom travels beneath the ice sheet where they form. Divers who study brinicles take precaution to avoid hypothermia or other cold water injuries. However, slow-moving, bottom-dwelling critters such as starfish and sea urchins are unable to move quickly enough to escape the flow. They may become ensconced in ice, completely frozen by the brine. That is how Brinicles earned the title Icicle of Death. Pool of supercold brine may also form and remain beneath the side of Brinicle formation. These so-called black pools of death can also be deadly to small sea creatures that wander through them. When salt-rich water leaks out of sea ice, it sinks into the sea and can occasionally create an eerie finger of ice called a brinicle. New research explains how these string fingers of ice form and how the salty water within sea ice could have been a prime environment in which life may have evolved. The study, published in the American Chemical Society's journal Langmuir, suggests that brinicles form in the same way as hydrothermal vents, except in rivers. Hydrothermal vents are spiny-looking towers on the ocean bottom where boiling, chemical-rich water flows out of the sea floor. The brinicle forming process goes like this. When sea ice freezes in the Arctic and Antarctic, the salt and other ions in the water is excluded from the water crystals, said study author Bruno Escribano, a researcher at the Basque Center for Applied Mathematics in the Basque Country in northern Spain. This salt-heavy brine accumulates in fractures and compartments within the sea ice. Inevitably, however, sea ice cracks and the brine leaks out. The brine itself is colder than the freezing point of seawater, since salt-rich water freezes at lower temperatures. Hence the reason people put salt on icy sidewalks in the winter, enabling the ice to remain a liquid when it's below freezing. Escribano told our amazing planet. Since the concentration of water in the brine is lower than that in the ocean, and water moves from high to low concentration, via osmosis water is attracted to the brine. But the brine is so cold that the water freezes, forming a descending tube of ice. Hydrothermal vents formed by an analogous method. Iron-rich hot water is expelled from the seafloor and then begins to dissolve, forming a porous shell of metal extending upward. Water then rushes in, moving from high to low concentration, rupturing the membrane and causing more metal-rich water to spurt out, extending the tube and repeating the process. Both are samples of chemical gardens, a type of chemical process and the name of an experiment common in chemistry sets that operates along the same principle and forms tubes of crystals that make plane-like shapes. Escribano said like that. Brine-rich compartments within sea ice have some properties that could have helped life originate, Escribano said. Inside these compartments, inside the ice, you have a high concentration of chemical compounds, and you also have lipids, fats that coat the inside of the compartment. This can act as a primitive membrane, one of the conditions necessary for life. They also contain a mixture of acidic and basic components that could provide energy necessary to form more complex molecules, perhaps even DNA. He said like that.